Okay, so in this video, we're going to go through the solutions or the walkthrough for the mid-semester exam. So this walkthrough at least is going to be kind of how I approached it. It might not necessarily be the intended solution or the correct solution, but it was a solution to get the flags and therefore the challenge to be completed. Now, as I do these challenges, I have already done the exam before, so it's not going to be the first time I've seen these questions. I'm still going to try and run through kind of the mindset that I have when I look through these pages, especially as a kind of CTF challenge. But please don't take this as the kind of holy Bible of what you're meant to think as you do the challenges in the exact steps and things like that. Okay, so let's have a look at our stuff. Okay, so I've got the mid-semester exam open. I also have the cookie editor extension installed just so I can easily view that. And I also have Wapalizer as well. I also have just Burp Suite on the side with the history logging there. Okay, let's have a look at question 1. Ooh, I got a message. Okay, so 6443 memes. Very first thing I like to do is we want to look at the reconnaissance of the page and have a look at what data and content exists as the low-hanging fruit. So no cookies at the moment. Let's have a quick look for robots.txt. Nothing there. And we'll also look at the sitemap.xml file. Also nothing there. So let's look at the source code now. We can see there is some CSS here. And then we've got some JavaScript code. And where's my word wrap? Here it is. We have this interesting thing here. Fetch memes from API who decided that token should have bearer in front of them in headers. We see that there is a fetch request. So that makes a request to the internet or to some site to API/memes. And we pass in this header here, which is the authentication token. This looks like a JWT token. Well, sorry, this does. And hopefully you can kind of identify that by the fact that it starts with EY, has a dot there, and has a dot there. So let's go to our good old jwt.io page and see if we paste that in. Does it look like a JWT? It does. It's got that first, second, and third bit that kind of match the format that we've seen before. And now, interestingly, when we look at this site, we see that there is a issue at time, which is kind of funny. It expired a while ago. Issued a while ago. It has two scopes, memes and flag, and then it has these things here, /API/API memes. We saw that before when we looked here. And then /API flag. So hopefully that gives you kind of the idea to think, okay, what if I try to use this token to hit one of these allowed endpoints? So we're going to try and do /API flag. I'm going to do that in Burp Suite just because it's a bit faster. Here we can see that there's a request to API memes and we're passing in the token. I'm going to right click and go to repeater. This allows me to edit the request and I'm just going to change this to, was it flag or flags? It was flag. I'm going to go send and then that's our first flag there. So very nice. We've got one answer there. Okay, let's look at the next question there. Question 2. Tutor forums. Okay. Again, let's look at robots.txt. Nothing there. Let's look at the sitemap.xml. Nothing there. Cookies. No cookies. Unfortunate. And let's look at the source code now. We can see that. Let's zoom in a bit. Just standard HTML. There's a page called reapostrophes. Page called free flag. Signing walkthrough and walkthrough for midterms challenges. Okay, nothing really interesting. Maybe we'll look at the headers as well for the site, which is Q2, this one here. And we can see that there's not really any information. It's no information at all. Useless. Okay, let's have a look at the pages. This post is hidden, so maybe this might be something that we're trying to access, but we don't know how. It looks like the title, though, reapostrophes, ends up being the link. We can see it there. Hey, we noticed that the server or the post is having the internal server while we redesign a backend. Please refrain from using apostrophes in post titles. Interesting. Let's look at free flag, signing walkthrough, and the walkthrough for midterms challenges. So free flag, that doesn't look like the format that we want. So red herring, we skip it. Signing walkthrough, sign in, useless. And then we get a internal server error. So I think, looking back at this post here, while we redesign our backend, please refrain from using apostrophes in post titles. We also see that in this page here, there is an apostrophe there, and we see it there as well, and that caused this page to have an error. Okay, I want to try and get rid of the apostrophe from mid-terms. And now we see post not found. If I do A, post not found, we go B, post not found, right? But supposedly if I put an apostrophe, things break, right? So why does an apostrophe break? Hopefully that makes you think of SQL injection, right? If we have some sort of query in our SQL statement that closes itself as a control with the apostrophe character and we put our own, we might be breaking the syntax when we put it in, and that seems to be what's happening. So SQL injection, that's kind of where we want to head and think towards. I'm going to repeat again, just makes it easier, and just very quickly, the most kind of common syntax that you might see when we do a SQL injection is we maybe want to skip some data, or we just want to bypass some sort of statement. So let's say the statement is select something from something where, and then we've got, A equals to that, and this is our query value there. So if we wanted to override this statement here, being able to control this, then what we kind of want to do is to change this to be like that, or 1 equals to 1, maybe a dash at the end. And this will kind of say, hey, select something from, well, select everything from something where A equals to that, which is always false, probably, maybe, who knows, or 1 equals to 1. That's always true. And then we comment out the rest. So what if we put this as our payload to replace the content? Let's go and put that there, paste and send. And we see the flag. Hey, you shouldn't be reading this. That's an apostrophe. So I go to render, hopefully. There we go. You shouldn't be reading this. And that's the second flag. One thing to note as well is if you can't put in this character here, what else could we do? We could put the characters here and then put it like that, right? So if A equals to empty or 1 equals to 1, and we're reusing this character which was part of the original statement, right? Like that, right? We put in the $1, which is whatever our variable is. And if we replace that with that payload, we go A is nothing, or the string 1 is equal to the string 1. So let's try that as well, just to test things. And we'll do that and press send, and we also get the flag. So that's kind of confirming to us that, the end of the query has that value there. Cool. Okay, so that's question 2, which is SQL injection. Now let's look at question 3. Question 3, our site has been deprecated, but we are still migrating content. You probably want our new site. I'm going to get rid of you just to the side and go to the proxy. Okay, new site. That's just quackerbank.com. So we're not going to go and investigate this just because it's not part of the challenge site itself. Content remove C file browser. Quickly, let's look at the robots file again. Empty. Let's look at sitemap.xml. Empty again, and we'll also look at the cookies, which again are empty. Source code, we see the link just to the official website, and then the /pages, which is this site here. About.php, flag.html, and translations. Let's just open them all up. This just looks like a directory listing on a website, so I'm not going to worry too much about that. We also saw in the source code just now that there's nothing interesting there. Okay, so about.php has, the kind of the data we've seen before. What else do we see? We see AU, FRES, and CN. Let's try click on AU, nothing. Click on FR. This looks like it is in French, translation by ChatGPT. Google thinks so as well. ES, Spanish or something, Estonian. I'm going to say Spanish. And CN, Chinese. Okay, there we go. Great. What do we do with that? Let's quickly look at the other sites as well. Flag.html, that looks quite interesting for us, that we might want to have a look and see how we get access to this page. And then we have a folder called translations about EN. Ooh, what happened there? That's funky. What else do we see? We see ES, we see FR, and we see ZH. Interesting. So what we can kind of see here is that EN, ES, FR, and ZH, they kind of equate to what we see here, all right? Australia is English, I guess. FR, French. ES is whatever this is, and ZH is, I don't know how to say it in Chinese. ZH. I don't know where the H comes from. Maybe it's there. 中文, which is Chinese, right? So C in there. Anyway, that's not important. What we do care about is the fact that every time we visit one of these different translations, we see here that the language changes to ES. We go to FR, it goes to FR, it goes to AU, it goes to EN. And that's kind of similar to what we see on this page here. So we also notice that this has an about thing here, and that's an about thing there. I don't know if that's related, but what if we try to break this language thing here? Let's go to AA, and we get a blank page. Why do we get a blank page? I don't know, it doesn't like us. Let's look at the response. What does the server say? It is a 200, and we get empty content, right? So that's not cool. Let's go to FR, we see that that works, and ZH, we see that that works too. Base 64, what does that mean? Oh yeah, the base 64 encryption, very nice. Okay, but that leads us to think, how does this page get these translations? Maybe it's accessing these files here, and it probably is. What if we go back a directory? Can we do that? It doesn't like us, right? But if we look back a directory and perhaps go back another directory, still doesn't like us, but we'll go to flag this time. What if we treat the flag file as a translation, and let's say the server perhaps is vulnerable to a path traversal vulnerability, right? If I send that in, we seem to have gotten the flag here. And yeah, so that confirms that there's a path traversal vulnerability. When we click through these files, the PHP file we see here, where it goes lang equals to something, this looks like it's loading it from this about and then the letters here .html. So if we go back a directory, we're basically on this directory here. We go back another one, and then we're here, and we're going to use flag as the supposed translation, and that's how we get that flag there. Cool. Okay, so that's question 3. Now question 4 is the Quakerbank password manager. Okay, so let's go robots.txt, my favorite, but it still isn't working, unfortunately. Let's go sitemap.xml, nothing there, and there's no cookies. Go to source code, make the admin password something other than admin. Okay, so maybe that means that the username is admin and the password is admin. Yes, it is. Cool. Because whoever registered the admin account used an insecure password, more important passwords are stored on the administrator account, right? So this has told us that there is maybe another account that we need to look at. Soy Central, Grayons, I don't care about that, I think. Let's go to the source code. Anything interesting? Nothing that I see of concern. Okay, just go to cookies now. And this time we have a user cookie that contains whatever this is. I don't know what that is, so let's go into CyberChef. Click there, and we're going to just paste that as input. Let's go magic, right? Our favorite CyberChef function that just tells us what it is. It's not really working. You can see that when it's baking or cooking, it's not really doing anything. All of this looks like pretty much gibberish to me. I'm not really happy with those results, so maybe it's not that. Let's do a quick base 64. That doesn't look correct. And maybe from a hex dump, that still doesn't look right, right? So what is this value? I'm just going to go Google it. Maybe it gives me an answer. MD5 reverse for something. MD5 hash for, that looks like a base 64 payload actually. So convert a string to an MD5 hash, right? So maybe this is the MD5 hash for this string here. And this looks like a base 64 string. Let's go and chuck that in to our CyberChef from base 64 admin. Okay, that's interesting, right? Admin is the account that we've logged into, and we've, whoops, not you, and we've gotten that as our cookie. I want to quickly try to change this. What if I change this to a 2? Save that and refresh. user not recognized, right? So it is carrying something about this cookie. Let's go and just set it back to the 1, save, and it's happy again with that. So what this has told us is if we can reverse the MD5 hash and then base64 decode it, we get the value admin, right? So what if we want to do it the other way? We want to maybe encode the string administrator as base64, and then we want to turn it into an MD5 hash instead, right? So let's try and do that. We'll put administrator as the input. We're going to then do a to base64, right? So that's that. And then we're going to do an MD5 hash of that. And that gives us this value here. So I'm going to go and copy paste that into our cookie, press save, fingers crossed, and we get the flag. Ignore that it says Q1. This used to be the Q1 challenge, but we made it Q4. Ignore that fact. Anyway, that's question 4. Now let's finally look into question 5. I'm not going to do question 6 in this video. Hopefully the tutors will either go through that in the tutorials, or they'll ask you, or you can ask them in private. All right, so the last one is quocked in. This looks like a LinkedIn clone, maybe. Okay, what do we see? Username, some fields, summary name, email, password, whatever, and this plus button. Upload your profile image. Interesting. Okay. I'm gonna bring you to the side because this looks like we might have some network requests going on. I'm just gonna clear this. Go right click, clear history. Yes. So now our history is cleared. Now let's do our basic recon. Robots.txt. Nope. Let's go sitemap.xml. Nope. And let's look at our cookies. Empty. Let's look at our source code now. We have CSS. That's local. Nothing interesting there. I'm going to close that. An image, which is probably just, yep, that dude here. Nothing interesting there. And then we've got, what else? Just the input fields. A GitHub URL, which I think was this one here. GitHub URL. Yep. Nothing really interesting there, just a bunch of fields, and then we've got a script at the bottom. Let's have a look at this JS script here. So can I open VS Code without doxing myself? You know what? That's fine. We're good. Okay. Paste. Cool, and let's just have a quick look at what's going on here. So we see we have some JavaScript to do clicking, I think. On this element, add a click listener to open a modal and to close it. So you don't need to understand JavaScript in its entirety to kind of do a lot of the vulnerability challenges. You've seen even in question 1 when I did it. I kind of just really quickly skimmed over the interesting things, which in my case was this one here. I didn't really look at the rest because this is all just, UI front-end stuff to make the page look nice. We just care about any credentials or, the critical path, which is the most important stuff when it comes to our vulnerability and exploit chains. Anyway, tangent. What do we see here? What I care about is the fact that it's doing a fetch request again, right? It's making a request to /load, passing in a post method, and then the data of our input.value. Let's have a look instead of just looking at the code. Let's have a dynamic kind of analysis of what's happening. So let's just go and fill in this site. I'm gonna go summary A B C at dddd.com maybe. F 0444444444 location what EFGHHHHH personal I and J. Right, now let's have a look at what's happening here. I'm just going to clear that again. Before I can even click it, something that doesn't match the expected pattern of GitHub or https github.com az/-- right? So this is regex. If you remind yourself from here, this is regex sort of value. And that's basically stopping us from being able to send the request because this doesn't work. Maybe we can also use this here. Let's just go save. And we made a request to /PPPPP and Now, interestingly enough, this is making requests to the local, well, this is making requests to the site itself rather than any external site. What if I change this to like HTTP, PPPPP, press, I'm gonna go HTTPS actually, save. Or what if we go to HTTP quokkabank.com test, save. It did make a request to the internet. That's interesting, right? Maybe we can have a look at why it's doing that or what it's doing. But I'm very interested in this thing here, right? Right. Press save, nothing's happening. So let's just go and fix that format. HTTPS github.com, and let's just go JJJJJJ save. Now there's a tick. To fill in your profile or to fill in your info from your GitHub profile, please click here. Let's click here. And what's going on here? I made a J. Germany. I don't know what this detail is. 1, 2, 3, 4, 5, 6, 7, 8. What happened here when do a post for JJJJJ? Hunter 2. That's interesting. What if I put my own or something? Or spam it first actually. Save. Click. Where did this data come from? I don't know. Interesting. I'll do my actual username, Featherbear, click save, click populate. Okay, so that goes to my site. But we saw when we did a random one here, it kind of gave us this pipe dream. What's pipedream.com/request bin? Inspect webhooks and HTTP requests. Create request bin. I don't want to sign in. Let's click back and go create a public bin instead. Your endpoint is this. Yeah, let's click generate test events. So this looks like a site where possibly we can send webhooks or some sort of like data to this site. What if I manually went to this endpoint here? Paste that in, get a success equals to true, and we see that at 10:17, that's now, we have a request to that site, and looks like it's from my computer. Let's go to that /test. Do we get a test thing here? We do. Okay, so this looks like, we can see the requests that a client makes to a sort of server like this here. What if we try pop that into that GitHub site here? Because we saw from before that we're actually passing in that data, and then depending on what data we pass in, we actually get different responses here. So maybe the server is sending some extra data either from this one here. Let's try put that in, pipe dream like that, and we'll go into here, and we can see that we're getting a request from Q5 Midsem, and that's our browser making that request. It's not logged because of the kind of proxy settings I'm using right now. But what about that other request here, right? If I try to paste that in, but it doesn't let us do that because of the regex. But nothing's stopping us from just going into Burp Suite itself and kind of bypassing the client-side validation, right? So what if we go right-click here, send to repeater, and then change the site to that, right? So instead of the GitHub site, we're going to change it to our own site, and we're kind of bypassing the fact that we need to do a regex check here. So paste, click send, and what do we see? We see success equals to true. That's kind of what we saw before. We also get a new request here from some site. It contains the flag actually, and we get it from Python requests 2.31.0, and so that's the flag there. Cool. All right. Now I'm gonna go over kind of the thoughts / things that you might not have seen or might have missed out just during the challenges, and I guess we'll just work backwards. So let's start explaining things after I drink some water. All right, so what's happening here is request bin is a kind of website testing or URL debug sort of test utility that allows you to send information to another site. You might not have learned about this or heard about this in your tutorials yet, hopefully you will get really acquainted with it, because this is quite important when we come to the idea of, server-side request forgery, where we're making a server do something that it's not really meant to do. And we can trick it into making certain requests to a computer, or to, in this case, another endpoint. Now, why is this important? I guess as you have been looking at actually, no, let's talk about this one, this URL here, right? As we try to make a request to, http quackerbank.com/blah, just look at the history here. As I make that request, we can see that the request gets made actually from the computer, right? The computer's making that outbound request to whatever address I'm making here, right? This is a client-side request to the internet. And as a consequence, it doesn't actually, appear and hit the server on behalf of the server making the request, right? It's making the request on behalf of the client or your computer. So your computer's reaching out. As opposed to what's happening is when we're sending a post request to the load thing, which is for this one here, we're actually telling the server to go and get that information, right? We don't see anywhere where our computer actually makes a request to github.com in these logs here. To make it more visible, actually, I'm going to change my switcher to proxy. So now absolutely everything through my computer or in this browser is going to be sent. I'm going to clear the history and try that again, right? I'm going to send a request to Pipedream in this case, press save. You can see I made a request from my computer to the Pipedream site, and I probably shouldn't have closed it actually. I'm going to have to create it again, my bad. Go here, clear that history, and we can see as I hit this endpoint, that's my computer making that request to this endpoint. We see in request bin as well, the history and the data, this comes from my computer that I'm sending, right? The user agent is Mozilla, blah, 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 Chrome, because it's a Google Chrome. When I do it from here as well, do the same endpoint, save, we can see that we also make a request to, I think it's this one here, we get success is true. And looking at the response here, we kind of get the very similar, in fact, almost the same thing. Take a screenshot of this actually, just pin that. And we'll open up this other one, and we can kind of see that they're more or less identical, right? We can see that Ian, blah, 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 root, Chromium, question 0. We don't see Windows, it's moved down a bit, but nothing interesting there. Now, when we trick the website to actually use, this site, the Pipedream site or the request bin, instead of GitHub, let's go to GitHub again, github.com, and I'm just going to go blah, 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 save, and then click that here button. What we can see here is when we make that request, right, we're actually telling the server, right, we're making a post request to the server to hit this site, and then we're getting some amounts of data back, right? Now, if I go and change this, and let's go repeater and change this to that same request bin or Pipedream site, click send, right? We can see that we've made a request, supposedly. The server's made a request to hit this thing here. If we go into our proxy site, we don't actually see that we have made a request to this thing again, because, we're not making that request, the server is, right? So the server is making this outbound request and getting this response that is then passing back to us. Now the question is, why are we getting a flag from making this request? Generally what happens is if we're making a server-side request, the server might be adding extra information that we might not see as the user, right? So as the user, we're saying, hey, go load this page or something like that. And maybe the server needs to authenticate to that page or to that other server. And in order for that to happen, it needs to pass in some sort of authentication, in this case, an X access token, and then the flag, which would kind of be like the password or the secret. It could also be a post request, right? Instead of a get request here, it could be a post request with some data in the body. In this case, it's a get request, so this is the solution for that. And so the key thing to understand here is that when we are making a request to the server and doing a server-side forgery, in other words, tricking the server to make a request somewhere other than GitHub in this case, but to this other site, we can't do it on the browser. And why is that? Because of JavaScript. There's some JavaScript code that basically just says, where's the pattern? Yeah, right. If the pattern is correct, then it will it'll show this thing here, which allows us to click that button. Otherwise, it says that it doesn't match and gives us that error, right? But this is all in the JavaScript front end or client side code. Nothing's stopping us from being able to intercept that request or kind of bypass what's happening and get the data and make those requests outside of the browser, which is kind of where Burp Suite shines when we have the repeater and just the other functions here. Okay, let's go back to question 4 now, which is the password manager, right? I don't remember this one. What's this? This is just the MD5 and base64. Okay, so nothing really to talk about this one here. These credentials here are a bit of a red herring, right? If you try to log in with them, I think you wouldn't have gotten access. Let's just try that. Whoops, crayons and I love soy 22. Login, incorrect username or password. So that didn't work. And we can see that we also don't get any credential. Do admin. We do get the credentials, but then after this stage here, because this isn't a JWT or some sort of other like decipherable string, that kind of leaves in the dead end to say, hey, I can't decode this as a base 64. Maybe it's a base 58 or something like that. But we've seen from doing in CyberChef that, even using the magic function, which kind of just does everything for us. Oh boy, what's happening here? There we go. When we try magic, right, it just didn't work. Usually if this was a legitimate like base 64 character, let's just go to that admin, what was it, admin? CyberChef, let's just open a new window. Right, if it was a base 64 character, like this, and I chuck that into the magic function, we can see that it automatically chooses the base 64, well, not chooses, but it tries the base 64 decoding function to give us that thing. The very fact that it just didn't work off the bat probably means it probably isn't the base 64 value, so that's why I gave up on that so quickly. Sometimes you can't decode a value, right? We did an MD5 hash. Let's just quickly recreate that hash, right? Administrator, we convert to base 64, and then we convert to base 64, and then we MD5 hash the thing here, right? So a hash in nature, you can't decrypt it, right? One way to find the kind of x input to fx equals to y is, you can't just do f dash y equals to x or x equals to f dash of y, right? Hashes are one way, so we can't do that. With a rainbow table, some sort of lookup table, if someone else has already created it, let's go to admin actually. If someone has already created that kind of pre-computed computed hash, that's all these results here, right? Someone has already kind of done a base 64 encoding of the word admin, which got that, and then they did a hash, MD5 hash of that, which resulted in this. All right, so the internet's really good. There's a few other websites like crackstation.net, I think. Yep, there we go. Which is a pretty useful hash cracker, right? When we're talking about hash cracking, it's not decrypting the hash, it's just trying to find some sort of lookup or some computed value that someone has already calculated or some server has already calculated. So I try to put that in. Don't know if that works actually because it's not just a password, but it did work, right? So that's the hash, and that's the kind of x value. So f of x equals to y, which is that there. That's all I'll say there. Let's go to question 3 now. Was that question 3? Yeah, that was question 3. Okay. This was the path traversal or IDOR in a way. I'm going to say it's more path traversal. So kind of just delving back into here, what's happening here is when we're going to visit a different language translation again, somewhere in the source code, it's looking for the directory of translations /about, and then it's picking up these files here. So I don't know if I can explain this anymore, but yeah, by putting in flag, we're basically saying, okay, I want to look at the directory. Okay, let's go back actually. Let's go back to en. Right. So when we're looking at, let's go FR actually for French. When we're looking at this page here, oh boy, let's change you to light mode. How do I do that? Boom. Okay. Where were we? So when I make a request to this site here, what it looks like it's actually doing is making a request to /pages/translations/about and then /fr.html, right? Where this value here is that value there. I'm gonna get rid of these. Cool. Just to solidify that understanding, when it's in the ES, which is Spanish, not Estonian, right? That's making a request to here. Oopsies. To ES, which is this bit here. All right. So looking at this about.php and flag.html file, right? These files here exist not in the translations directory, but elsewhere. So we see that it exists in /pages/flag.html. So if we know that ES is equivalent to effectively what is this, then we want to change this ES value to kind of allow us to access here. And so the best way to talk about that is maybe let's put a $1 or something. I'll just go language, right? Language is here. So that's our language here. And we want to go back all the way to transition from that into flag.html, right? So how can we change this string here to be like this? So if we think about directories, let's say in Linux or Unix or even Windows, right? To go back a directory, we need to have this dot value here, dot slash actually, right? And that will basically say, hey, I want to go back a directory into translations, right? So if I have lang equals to dot/es, what does this translate to? Let's copy that. And that's going to become lang is equal to .es.html. And what does this actually translate to? If we have a directory here and we want to go back a directory, we end up as like this, right? Now that's still not what we want. We want to go all the way to the root directory and skip translations. So now what if we put // es, right? What this is now saying is we're going to go back a directory, back another directory, es. And that's effectively saying I'm going to go to, how do I best write this? About, right? So about, whoops, about that, and then we're going to go to the root, and then whatever, es.html, right? Now there's no es.html in that root directory here. There's actually pages in front of everything. Let's just quickly go and add that in, not to confuse things. Cool. Important there as well. So if we want to get flag, instead of writing es, we could just possibly write //flag. And that gives us our solution basically because by the kind of path traversal vulnerability, we're able to modify the requests, which resolve, not requests, the language, which tricks the server into going, okay, I want to load this page here. Now we want to resolve this by getting rid of that. And we want to resolve this by getting rid of this. And we get pages/flag, which is our solution there, right? So I can't view it, but the server can view it if we trick it into going lang equals to // Now, one question you might have is, how come I can't access the server? Oh, sorry. How come I can't access the flag, but the server can? This is where we talk about file privileges. Basically, the server has access to quite a lot of files in the system because often this PHP server might run as like an administrator or as a root. Some reasons for that is just because it's very hard to write a server that has access to only the very correct amount of permissions and things like that. So often server administrators actually just give full access to the web servers because they trust, or at least they wrongly trust, that the servers are written correctly and that they only access what should be accessed. But with vulnerabilities and security issues that like this, if we can trick the server into accessing some other pages, then maybe we're able to do this and kind of trick the server into making requests. Now, just going a step further as well, if we don't want the flag, maybe we could also go all the way to the root directory and go like etc password. But why does that not work? One, maybe the server isn't actually running as like a full administrator or as full root, which means that it can't actually access this. But also have a think about the fact that when we put in the flag or the language, sorry, it puts in the .html value by itself, right? We can't control what happens after this part of language. We can only control this bit. So we're trying to access, on the file system /etc password. There's no way for us really to be able to put in or to stop this .html from happening. Now there are some ways, but it depends on the server and kind of how the server is set up. But in this specific example, that doesn't work for us because this thing is appended at the end automatically, which means that for us, we can only access files that end with .html. Now that's technically a lie, but I'm going to just end it there for now because there are a few ways that we could, let's say the server is allowing comments or something. We could put a comment there and then we can end it there. But in this case, we're just going to end it there and say for a web server, that didn't work. Okay, let's go to Q2 now. q2.midterm.qualcommbank.com. And this one, I think, self-explanatory as a SQL injection challenge. Basically, this page here had an error, and that error is because there is a apostrophe there, right? And so thinking about the query where we go select something from, I don't know, pages where page name equals to $1, where $1 is the value here. If we can trick right? If we can trick the server and pass in a control character like an apostrophe, we then can modify the rest of this statement here. So we go blah like that, or 1 equals to 1, and just put a comment. Then the query will be select star from pages where the page name equals to this, which might not be true, or true, right? And this will always evaluate to true, which means that we'll always get at least the first page, or an amount of pages, or all of the pages. And then just to null out the rest of the statement or the query, we put in the comment thing here. But what I did in my solution is I just did this. And what that does is by putting this as my payload, right? When this gets replaced from here, we actually close the existing quote apostrophe at the end, and we're able to still have a legitimate and correct, syntactically correct payload. So select star from pages where page name equals to blah, or the string 1 is equal to the string 1 closing blah, right? So just doing it one more time, I'm going to paste that there. Don't have to do it in burp suite. I think I can just do it here, enter, and that's the flag there. Cool. And now let's finally go to question 1. Just finishing our working backwards. We just have this page here, and we have an authorization header here, not a header, a token. Looking into, let's go token.dev this time. This is just a different website. It's in dark mode, so my eyes don't hurt. We paste it. It's a JWT string because it has a JWT type. And then it's got a bunch of scopes and allowed endpoints here. So it tells us that there's probably some endpoint called /API, probably some endpoint called API/memes, which there is, because how do we know that? That's what we're doing here. We're making a request to API memes, and we have a request to API/flag. So the solution is to make a request to API/flag. But what happens if we go to /API, right? Just as a kind of learning exercise. We get this. It says Swagger UI, API for accessing memes and flags. API keys must not be exposed, right? So what is this? So Swagger, if we just go to Google, Swagger is an API documentation and design tool for teams. Basically, if you haven't seen a Swagger documentation before, it's like a fancy way to demonstrate and allow people to test your APIs. In a kind of nice and interactive way here. So, let's say for whatever site I just found myself on, myro.medium.com, I can look at the kind of API endpoints or the documentation for these endpoints. I don't know if there's any better documentation example. Pet store. This is an example. Cool, right? Looking at this page, everything about your pets, right? If I wanted to, for example, add a new pet to the store, right? It tells me that the requirements I need for that request is a body object that passes in this amount of data as a JSON file. Or maybe I wanted to pass it as an XML file. We no longer teach this part in this course for this offering in 2024. But if I made a request with this data or this format of the data where the category is a string, the name has a name, blah, 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 we'd be able to make a request to the site. This is kind of just the behind the scenes sort of thing. Don't need to know this. And then we can pass in the authentication, things like that. So it's a very nice way to kind of expose your documentation to the users without it just being like a massive textbook or something that you can't really interact with. In this case, we're given this page, so maybe we could copy and paste the authentication key, which I got from, oh boy, let's just go and turn you back to this. I'm going to refresh the page, refresh this page as well, and we can see that we have our request to /API, not actually what I want. I'll clear the history. It's getting a bit messy. Refresh the page. And we have a request. Well, so that's the wrong challenge, actually. That's Q2. We should be looking at Q1. Cool. We have a request to /API/memes, right? So we saw that in the API documentation, actually. /API/memes gives us this response here. And we can see that memes, and then there's an object as an array as objects, array of objects. We can see that's an array of objects, right? And that's the request to API/memes. If we look at the gets flag, it's a gets request firstly. The path name is flag. And then this is the response. We can see there's no actual input we need to give it, other than what seems to be the authentication header, which is this. So basically just repeating that, changing that to flag, and then send, and that gives us the flag there. Hopefully that made sense. If it doesn't make sense, please do ask your tutors. They will be more than happy to help you. Ask Chris, ask me, ask Hamish, ask the other tutors. We hopefully will be able to help you. Yes, hopefully that all made sense. If it didn't, oops. Yeah, please come and ask us. Yeah, anyway, good luck with your reports and the other questions. Now, as for Q6, I'm not going to talk about it, but basically the hint for you is more SSRF, and just have a look at, when I make a request to the website, what actually happens in terms of the network stuff here, right? Have a look at the cookies, have a look at the robots file, see if that gives you any information. But have a look at what actually happens when we send data and receive data and stuff like that. All right, cool. Hope that was useful. If not, oh well, you just wasted an hour of your time. Lol. All right, bye-bye.